Okay, so hopefully you've watched the why we use Docker and intro to Docker video. Now I'm going to go a little more advanced. I'm going to show you how to use Docker to make something like a pipeline. So I'm going to add a few steps. I'll show you two different ways we can do this. So previously I showed you that to make our pipeline we had to create a Dockerfile. So we can cd into our echo chamber test, look at our Dockerfile, and you can see the only thing we really imported was the Ubuntu image. And we can tell it to keep setting stuff up. So Ubuntu uses a program called Aptitude, which is kind of like Brew for Ubuntu. It's a package manager, and it's where they have people build like precompiled packages or instructions to install stuff. So rather than you having to build it from the source code, which is kind of over the head of a lot of people, and even I get really tripped up by it sometimes, having to figure out all the different things you have to install to make it work. It just makes it work, which is really nice. So say we want to do something like add a few programs like Bowtie and SAM tools. The first thing, since this starts as a base image, it needs to get information for all those packages. So we're going to run the program aptitude get -y. So -y just means anytime it asks you, do you want to do this? It always answers yes. And we're going to update, which is to grab all the current package information. This won't work without that. And then we're going to tell it to install Bowtie and install SAM tools. So let me just go ahead and we can go through. I'll do everything except for Vim here. So we'll go ahead and here. We'll leave Gawk off this list. So I'll show you a different way to do this in a second. So okay, so we'll save our Docker file there, and then we'll run our build command again. So we'll say Docker build, and we'll give it the name Chipseek because we're building the Chipseek pipeline. And then we give it the path to where the Docker build file is. And so we run this. This is going to run for a bit, so I'm going to pause it while it runs so that you don't have to watch it kind of compile. We'll start again once it's done. Okay, so that's all done. So now what that means is if we run the Docker image called Chipseek, so we say Docker run -it Chipseek, we can say Bowtie, and now the program's installed. And SAM's tools, all those programs are installed. Vim, however, is not installed. So here's another kind of interesting way. So if, say, apt doesn't have the correct version of program you're running, which is true with SAM tools and maybe Bowtie, so there's a lot of ways to get more up-to-date programs, and I have to do this a lot for a lot of R packages. You may want to go ahead and install them manually. So we can do that. We can create a container based off an image that has most of our stuff installed, and we can do apt-get -y vim. So we can install Vim from within the container. And I'll show you how to kind of save the changes you made in a container back to an image here in a second. All right. This should be done pretty darn quick here, hopefully. Okay, so that's done. So now what we can do is we can exit our container, and you remember before I showed you Docker containers. So this is a bunch of commands, a bunch of commands for looking at previous containers. So we're just going to look at the one we just ran. a second ago. And remember, I told you they have these weird names. So we're just going to grab the name for this one here, and we'll say Docker. And then Docker has this command called commit, where you create an image from a container's change. So this is very helpful if you have to do kind of more complicated stuff to build your container the way you want. So we can say Docker commit. Let's make sure I'm doing this right. Yes. So Docker commit, and then we give it the container's name, and now we tell it to say chip, send it to the Chipseek latest image. Okay, so now we've done that. So now if we go into Docker run -it Chipseek, now if we do vim, now it's installed. So if you don't want to build a really complicated build file, you can do that. The advantage of build files is that they're easily reproducible, but the disadvantage is if you have any issues with kind of complicated building of programs, then it's not going to work out. Or if you're grabbing files from kind of weird places. So for this program, we're also going to grab my arc parser program that I wrote. Oh, so apt-get install wget. Yes, we need the wget program. So we could stick it in the file and tell it to copy it over, or we could just grab it here. And we'll just move arc parser. Let's change the chmod 777. So that makes it executable, and then we'll move that to the top bin. Now we can call that. Oh my goodness. The awk version seems to be way out of date, which is annoying. Let's install that. It's really strange. I thought we had installed that, but I guess not. There we go. Okay, everything's good to go now. And so again, we just made some changes, so we're going to want to save this thing. So we got to get the new updated container name. So Docker container ls, all right, -a. So we get this stupid Gallant Goodall, and we do Docker commit Gallant Goodall to Chipseek latest, and now that's saved. Okay, so I could go over some more of this, so let's go ahead. I'm not going to run through basically the making of the whole Chipseek pipeline. Essentially, you could do it two different ways. We can go into our shared folder. We'll get rid of these files because they're just example files, and we'll do our chipseek.sh. So in here, I'm just going to put our program here. That'd be an easy way just to copy that into your shared folder. And then I'm also going to get some E. coli files here that I have that's just for doing an alignment example and a Chipseek calling example. I'm going to download those real quick. And then after this, I'm going to show you how to convert this into a Singularity package, and then kind of go over how to how to use this for on Chipseek. Sorry, I'm trying to think about like 3 things at once, and my brain doesn't work that way. Oh, so one thing, so if you don't want Singularity or Docker coming up with its own names, you can give your containers their own names. So we're going to call this one Chipper Goat. So I'm saying, okay, we're going to start up Chipper Goat here. The container called Chipper Goat from the image called Chipseek. Okay, so we're in here. Let's just see what this is. So we'll set home to /home/user or home equals /home/user. So let's go ahead and try and run our program here. Okay, here we go. Sorry. Okay, so we're going to run this command here. See if it works. What did I call it? All right, I just changed the name is all. This isn't running right. One moment, let me fix this. All right, for those of you following along at home, I had to download the program on zip, and I also had to change one thing inside my Chipseek file. I had to change where the source for the ARC parser was, because originally I was just dropping it into the home directory, and as I showed you before, I put it in our root bin directory. So that's what was going on there. All right, so now I've got everything undone. We run our little command here. By little, it's a pretty large command. So basically, I'm just running my Chipseek program that I wrote. You can go back and examine that in detail. And we're using the E. coli genome, and we're just aligning it and running Chipseek on it. So I'm going to run that. If you want to run along with it, go ahead. I'm going to pause until that finishes. Okay, so that ran. And we've got our folder here called E. coli for. So we could get it out by just moving it over to the shared folder, but I'm going to show you also a different way how to get it out of there. So let me go ahead and tell my wife to quit messaging me. Put this on silence mode. Okay, so let's go ahead and we'll do exit here. And then one way, so if you remember, we named this particular container Chipper Goat. So if we do Docker container ls-a, we see up here we've got our container we just ran called Chipper Goat. So what we can do is we can copy stuff out of that container. So say you forgot to make a shared instance, you shut it down, you're like, oh man, I just ran something for like 6 hours on that thing and I need the file out of it. You can do this Docker copy, and then you tell it which container, so Chipper Goat's our container, and then you give it a path, a full path to where the file is. So for us, it's home/user/E. coli for, and then we're just gonna put up a folder here. Oh, that's no good. Let's just grab that whole folder there and put that. There's not much else in that. Oh, there's a shared folder. Things could get real crazy. Let's check this out. All right. So let's look at the user folder. So, okay, there's all our information that we wanted there. So we were able to grab it out of there and bring it into our space. That's what's in here. Okay, so that's just another way to get files out of a container. So one thing you may be thinking is, okay, if the files are in the container and I'm not in the container, is the container taking up space? And the answer is yes, it is. So an important step to do when you're working with Docker is to get rid of stuff. So you can do Docker container prune. And what this will do is this will basically delete any containers that aren't being used. And you could give a specific container name, so we could say prune chip or goat. I guess remove probably is the right. So we could get rid of chip or goat like that. Or if you do prune, it just gets rid of all the closed ones. So we'll say yes, and you can see we reclaimed some space, and the chip or goat one would have been larger. So these do take up hard drive space. So be sure and clean your space. I don't know if it automatically gets rid of them when you shut it down or not. Okay, so the last thing we're going to do is we're going to go over how to make this work with Singularity. So let me look at something real quick, and I'll get you an address for where to download Singularity. So Singularity has a website. That's scilabs.io. That's where you can find it. You can find examples of how to download it and run it here. I'm not going to go into that because it's not overly complicated, but it's kind of outside the scope of what we're doing right here. But just know I've downloaded it and installed it. And so what's interesting about Singularity is it was kind of designed to take advantage of Docker. So it works with all the Docker containers, but it also doesn't require all the weird root privileges that you require for Docker. So it was designed to run on high performance computing resources like we've got at CHPC. And so it's pretty easy to convert one container to another. And the easiest way is if you've already built your image, you can do Singularity build, and then you give it your name you want for your Singularity container. So this chipseek.sif, so that stands for Singularity Image Format. And then we say our image is coming from the Docker daemon, which is the one running on this computer. You can also grab it off of Docker image repository. You can look that up yourself. And we're saying, okay, from the local computer, I want you to grab Chipseek latest, so the Docker image here, and convert it to a Singularity image. And that'll start running there. I'll pause it till it finishes. Okay, so that's done building. So now you can open that with Singularity. So Singularity shell is the same as Docker run-it. It's just an interactive session. And now we can look here and we can see we've got these programs installed, bow ties on here. So it's essentially the same thing, except for there's a few important differences. Like in Docker, you are the root user when you're inside the container, where Singularity grabs all the user information and brings it over. So if I say, who am I? It'll say I'm Jeff. So this is sort of nice and sort of a pain. I'll show you why here. So if we go to the root directory here, we go to the home. So now there's also my Jeff home directory, which is really interesting. So Singularity also grabs the original file system and makes this weird mashup between the containers file system and the original file system, which can get really confusing and cause problems. And it kind of contravenes one of the super useful things about Docker container, and that's if you have stuff installed already that interferes with the programs that you have running in the container. In Docker, that's not a problem because it's almost completely unaware of the computer it's running on, whereas in Singularity, it can be an issue because it's essentially like you've just tacked on a computer onto the system that's already there. So, so like I have Python already installed on that, the outside instance. So if we exit here, and I say, oops, if I say Python, okay, maybe I don't have Python installed here. So let's see here. What do I got? I don't have anything installed on here hardly, because this is basically the only thing I use this for. But basically, I've run into the issue where I have Python packages that interfere with ones that are running in Singularity, and that cause some major issues. So there's some stuff you need to work around, and I am trying to find ways to do this kind of automatically for Chipseek, but just be aware that this exists. So it's a double-edged sword. It works really great because then you don't have to bring in files. I don't have to like bring in all of my index files for Bowtie and stuff like that on Chipseek. But at the same time, any files I have that'll interfere are there and will interfere. It's a real pain. So that's just kind of a more advanced how to build a pipeline and run it, and how to convert it to a Singularity image. And again, Singularity is on Chipseek, so we can run things on CHPC, whereas Docker is going to be more useful for things like 7bridges. They run Docker. And any online cloud resources. So this is essentially what cloud resources are, is you log on, you have a Docker image, that blank computer has Docker running in it. It just loads up your image, doesn't need to install any of the programs. It's already got them in the image, and then it runs it. And then when it's done, it gives you your files out and then blows up the container, and the next person can use the computer. So that's kind of the advantage of containers, is that in the future, probably people aren't going to need their own computers. They're just going to need a way to connect through the internet to a cloud computer, and then you'll just do whatever you want. So when people are running stuff like Stadia Online, which is online gaming, same thing. It's just a container with a computer running a virtual machine of whatever gaming platform you're on. Or anytime you use Amazon Web Services or Azure, which is Microsoft's compute stuff, again, these are all just going to be a bunch of computers that are running Docker essentially. All right, so hopefully that wasn't too confusing with all the starting and stopping and me having to fix a few things to make it run here. Again, if you have questions, just ask me. All righty.